Hello everyone, how's it going? We're going to be looking at another limit problem. We're going to be applying L'Hopital rule. We have the function limit function x minus sine x over x minus tan x, and we're trying to evaluate the limit of that function as x approaches 0. So if I take what I have right now and I plug in 0, or attempt to, for x, in the numerator I'll get 0, minus sine of x, which is also 0, and in the bottom x will still be 0, and tangent x is also 0. So I already know I have an indeterminate form. So indeterminate form, there's 8, positive, negative, infinity, infinity over infinity. Anytime you have that, it's an indeterminate form. So I'm basically going to come over to the expression right here, and I'm just going to take the derivative of the top and numerator independently. By that I mean what we're really doing is saying f prime of x over g prime of x. We're not using the quotient rule. So when I do that, we come up with 1 minus cosine x, and the bottom we get 1 minus secant squared x, and then we apply the limit, and we get, for cosine x at 0, we get 1, so 1 minus 1 is going to be 0, and then here, secant squared x is the same as having 1 over cosine squared x. Cosine squared x at 0 is 1, so I basically have 1 minus 1, which gives me 0 over 0, and that's another indeterminate form. To solve the next, to move on from there and try to find the limit, we have to apply the rule again. So sometimes we'll apply it more than once. When I apply it here, we only have x in cosine x for the numerator, and that's going to be sine x. The negative and the negative cancel. For here, we just have secant squared x. So we actually have a product rule. We're going to bring 2 down here, and we're going to get negative 2 secant x, and then the derivative of secant x. I want to try to evince the quotient rule a little bit more. You're going to have negative 2 secant squared x, and then you're going to have the derivative of secant x. So we have secant x prime. Alright, so when we try to finish this right here, let me zoom in. Numerator stays the same, but for the denominator, we have to take the derivative of the secant x, which is going to be secant x tan x. So we have negative 2 secant squared x, and then derivative of secant squared x is secant x tan x. So this becomes squared. And then now we apply the limit. Limit of x approaches 0. We know the derivative of sine x, so that is just 0. And for here, we're also going to get 0 because we're going to get 0 for tangent x because tangent of x is 0. So we have to apply the rule again. But before we apply the rule, we can do some simplification. So I'm going to take this, copy it, whoops, copy this over here. When I look for things I can simplify, this is what I see. The numerator, that'll stay sine x. I'm going to simplify there. But over here in the denominator, I can break this down as -2. That's going to stay out front. Secant squared x is the same as 1 over cosine squared x, and then tangent x is sine x over cosine x. So if I want, I can just rewrite this and call it sine x over -2, and sine over cosine, I'm going to have one factor of tangent x, and then I'll have two factors of 1 over cosine squared x, which I can just call, I'm just going to call that secant squared x. And then now we apply the L'Hopital rule one more time. All we did just now was simplify. So, hello everyone. I'm picking back up from where I left off. I just erased the board and cleaned it up a little bit. So we're applying the L'Hopital rule one more time because we have another indeterminate form. So derivative of sine x, that's going to give us cosine x. And then for the denominator, we're going to have -2. And then we're going to be applying the product rule here because we have x and we have two x's, tangent x and secant squared x. So when I do that, I have tan x, and then derivative of secant squared x is 2 secant x, which will be secant squared x, tangent x. That'll make this squared. And then we have plus the derivative of tangent x is secant squared x, and then secant squared x stays the same. Multiply those two together, and you get secant to the 4th x. So we have secant to the 4th x. And then we apply the limit as x approaches 0. Alright, so let me resize. Alright, so when I apply the limit in the numerator, I'm going to get 1 because cosine of x is 1. And then we have -2. And then tangent squared x, that's going to be 0 because tangent has 0, 0. So this whole term here is going to be 0. But at secant to the 4th x, that's 1 over cosine. Cosine at 0 is what we have, cosine 4 to the x. And then we plug in 1, and we get 1 to the 4th, which is just 1 over 1. So we know we're going to have 1 here. So that's 0 plus 1. And the answer is -1 over 2. Have a good day.